Hello, group. It's Friday, and Mr. Dairyman is not here. You're in direct right now. Would you quickly turn into your notes to page 6? Page 6 is what you're looking at right now in your notes. Pause me right now and go find page 6 so you can be ready for the next instruction. Page 6. All right. So we're looking at notes here on the periodic table. We have two blanks to fill in. We're going to quickly also fill in notes on our metalloids, metals, nonmetals, and metalloids. That's it. So we're going to put in that information. You're going to see the difference between the metals, nonmetals, and metalloids by the time this is over. We'll take a look at the periodic table in general. You'll know what the blue means. You'll know what the black line is, the green, the yellow, and so forth. So getting started here with the periodic table, the first thing we want to put into our notes is the vertical versus the horizontal columns. Okay, so the periodic table has a system, and if we go vertically, which would be straight up the rows, vertically up this way, each vertical column on our periodic table is called a family of elements. And a lot of these families have names that we're going to try to remember. Okay, families. Elements within the same group or family, they have similar but not identical properties. We'll see some families in a moment. Horizontal rows going across the periodic table have a different name. They are called periods. Periods have patterns to them, predictable patterns where you can see the changes as you go across the period. So as you go across the row, there's a pattern of change. We'll take a look at that as well in a while too. Erasing as quickly as I can, and at any time pause me to write. If you're getting behind, just press pause on your video and I'll be right back with you as soon as you need me. Let's go up into a little system, a little app I have here, and take a look at it. The only thing different about this app is hydrogen is in the middle, and it's supposed to be out here. Let's just bear with it. So hydrogen's in the middle here, should be out here above lithium. Okay, taking a look at the first family. This family right here, notice the elements all in this family. This is called the alkali metals, and we can click on each one of those families. And something that this family has in common, if you look at the outer edge, is that it has one electron in the outer shell. So all of the atoms have one electron. In family 2, you guessed it, there are 2 electrons in each outer shell. So look up here, 2 electrons in the outer shell. If you go over to group 3 or family 3, 3 electrons, count them, 1, 2, 3. Aluminum, 1, 2, 3. I wish they showed those. Group 4, 4 electrons in the outer shell. Group 5, 5 electrons in the outer shell, 6 electrons in the outer shell, 7 and 8 electrons in the outer shell. By the way, this family is a popular one right here. We call this the halogen family. And this is the noble gases. The noble gases are all gases, obviously, and they're popular for having 8 electrons in the outer shell. All of the elements have 8 electrons. And they're famous for having 8 electrons and not wanting to give up or take in any electrons. They stand alone. They are by themselves. They do not like to bond with other atoms. Therefore, they are nobles. Sort of better than the other atoms, or so they thought. Noble gases, halogens, alkali metals, alkaline earth metals. Oh, I forgot the transition metals in the middle. Big family, and these are all metals that have similar characteristics as well. So lots of different families of elements. Looking across at the period, there's one period that's just hydrogen and helium, 2 periods, 3, each one is a period. Okay, so as we go across, we have 1 atom or 1 electron in the outer shell, 2 electrons. It kind of builds 3 electrons, 4, 5. Also, the atomic numbers increase as you go across. Sodium's atomic number to magnesium all increase as you go across. So we have 7 periods to think about, and then we have our families. One little tidbit, the alkali metals are known as the salt formers. Okay? They love to bond with the halogens. So just to give you a couple examples, sodium loves to bond with Na, loves to bond with chlorine, and that gives us NaCl. That's table salt. Or sodium bromide, another kind of salt. So when the salt formers bond with the halogens, they form salts. We can have potassium iodide, or otherwise known as Ki. Again, a salt formed by the halogens in alkali metals. Pretty cool. So just a quick lesson there, quick look at families and periods going across the periodic table. Back into our notes as quickly as possible. Moving on down. Now we have 3 categories here we want to look at quickly. Our metals, nonmetals, and metalloids. Going up into the periodic table here on this in your notes. Please write what I write. Press pause anytime if you need to. The blue is our metals. Write this in here with me on your notes. These are all metals, all the way down through everything that's blue. The yellow are our nonmetals. Write that in. Kind of makes sense because didn't we say that the noble gases are here? They're nonmetals. They're gases. The green, heading on down through, on each side of the staircase line, has a funny name I'm sure you've never heard. We call them the metalloids. And these metalloids are sort of the in-between elements. They have some of the characteristics of metals, and they have some of the characteristics of nonmetals. So they're sort of like the in-between, the halfway point. You'll see that metals have really unique characteristics, nonmetals have their own characteristics, and metalloids somewhere in the middle. The black staircase line is a dividing line that separates metals and nonmetals, and the metalloids are found next to that line. All except for aluminum, and that most definitely is a metal. So even though it touches the staircase line, aluminum, still a metal. It's not a metalloid. Metalloids touch the staircase line. Hopefully that gives you a little brief overview of these 3 categories. Let's go down in our notes and look at the characteristics of the 3. I will write as quickly as I can, I promise, to make this go quicker. Metals, here we go. Let me get my marker. They are found on the left side of that infamous staircase line. I don't know if you want to do what I do here. Here's your staircase line, talking to the text. Metals include aluminum, even though it's touching. And metals are identified by their shine. Some call shine luster. You need to be ready for that. Luster or shine. Metals have high melting points. They have to get really high before they become a liquid. They have high densities. Remember we talked about sinking and floating? Most metals will sink readily because their densities are above that of water. They're high. Metals are, here's a fancy word. Say it with me to yourself. They are malleable. Malleable. And that means that they're able to be beaten or hammered into a thin sheet. They're soft. They can be forged when hot. They can be shaped by someone into whatever shape we need, like aluminum foil or sheet metal. Little interesting fact: gold is so malleable it can be pounded into a sheet as wide as this classroom. Just 1 ounce of gold can be pounded into a huge sheet because it is so malleable. It's kind of hard to believe, but it's true. Metals are also very ductile or ductile, however you want to say it, it's up to you. Ductile or ductability. and it's sort of like malleable but a little different. This time, instead of beating the metal, we're going to stretch or pull it into a long wire. Again, gold is so ductile that 1 ounce can be pulled into a wire, believe it or not, 2 or more miles long. Now think about that. 1 ounce of gold in your hand can be stretched into a wire 2 or more miles long. Interesting stuff. Metals are also very good conductors of electricity. Very good conductors of heat and electricity. And if you paid attention during my one video, that's because metals have 1 or 2, remember this? They have 1 or 2 valence electrons. And when you have very few valence electrons in your outer shell, those electrons can become electricity very quickly. Pause me if you need to while you finish up. I'm going to erase. Moving right along quickly, down to the nonmetals. You'll notice that a lot of their facts are simply opposite of what we did in metals. Metals are found on the right side of the staircase line. They are not shiny, but rather dull. Opposite. They have low melting points, low density. So a lot of gases and nonmetals will tend to rise up because they are less dense than even air. And they melt at, low temperatures. Nonmetals are brittle. They will break easily or flake. And instead of being good conductors like metals, the nonmetals are poor. And this is because their outer shells, their valence shell, instead of having only 1 or 2, their valence shell has more electrons. I'm just going to abbreviate there for time. So the valence shells in nonmetals have more electrons than metals, and therefore those electrons are not as easily transferred out of the atom. Pause me now if you need to slow down and catch up. Okay, thanks for hanging in there with me. We're right on down here to the metalloids. They are found along the staircase line. They have to touch the staircase line. Do you remember which one we don't count, though? It's right here. We do not count aluminum. Metalloids can be both shiny or dull. Remember, they share those properties. Metalloids have fairly high, somewhere in the middle with melting points and densities, kind of medium or so. And that's the whole principle behind those metalloids. They're somewhere in between. And they conduct heat well, or better than nonmetals, but not as good as the metals. Now when it comes to electricity, metalloids, because they let some through but hold back some electricity, they're not great conductors. They are known as resistors. The electricity goes through a metalloid, but not very well. And resistors tend to make heat. So think about electricity to make heat. Toasters, electric blankets, curling irons or flat irons, they're using metalloids so that they can make heat for your hair or to keep you warm in some way. Again, press pause. Actually, you don't have to press pause, I don't believe, because I think we're done those notes. So again, thank you for hanging in there, following directions throughout my day. Please do what you have to do and work quietly as you move on through your rotations. And I will see you again real soon. Bye-bye, all.